Today we're going to be talking about how we can write quadratic functions and models when we're given information. Instead of taking the equation and graphing it and finding out some values, we're going to go in the opposite direction. We're going to be given some values, given some points on a graph, and use that information to find the equation of that specific quadratic function. Remember, we have three forms of a quadratic function. We have vertex form, intercept form, and standard form. And what we're going to do is look at the different ways we need to approach those problems. So with vertex form, remember that vertex form is y equals a times x minus h squared plus k, where h and k are the vertex. So what we're going to do is we're going to solve this example 1 down here while looking at the steps. So I'm going to just write this down here again so we can refer to it easier. So the first thing we're going to do is we're going to substitute values of the vertex in for h and k. That means we need to look at our graph over here and see where the vertex is. Okay, our vertex, we have h and we have k. Now that probably wasn't a good choice. And k. Now we look at the point. We have another point on this graph that we can substitute x and y. So let's highlight again. See, we have x and we have y. And you'll notice that the only thing I don't have highlighted is that missing a value. So we're going to solve for that missing a value. We can go ahead and do that. So we have 5 equals a times 0 minus negative 2, so plus 2 squared, minus 3. All right, so let's simplify this. 5 equals a times, well, 0 plus 2 is 2. 2 squared is 4, minus 3. Okay, then when we add 3 to both sides, we get 8 equals 4a. Divide both sides by 4, and a is equal to 2. Now, we are not done at this point. Yes, we found that missing a value, but remember, the problem is asking us to write this equation in vertex form. So now we have to go over here. Y equals our a value that we calculated was 2. And when we write the equation, you need to remember that x and y remain variables. So x minus h, which again was negative 2. So we make it a plus 2 in the parentheses, and then minus 3. So this is the equation for this graph shown here. So what we did was we took our h and k value for the vertex, we took an x and y value from the point they gave us, and then we plugged that in to the vertex form and solved for a. What you could always do is you could double check your answer here. You could graph this in your calculator and see if you plug in 0 for x, do you get 5 for y? So I guess I can show you what that looks like real quick. All right, let's turn this on. So 2 parentheses x plus 2 close parentheses squared minus 3. So now when I trace, I hit the trace button, and you see when I type in 0, the y value is 5. So I'm confident that this is the correct answer now. All right, now let's look at writing a quadratic in intercept form. So remember, intercept form, x minus p times x minus q. And in this problem, what students will often make is a mistake they'll make is using these y values as our point. We want to use those x-intercepts for our p and q value, and then use this as our point down here. So again, we're going to look at the instructions. So substitute the values of the intercepts in for p and q. And then substitute the values of the other point for x and y. So let's do that. So we're going to have -4 equals a times x. Well, x is -2 minus p. It doesn't matter which one you put first, -3 or +2. So we'll do -2 minus -3. And then x again, and -2. And a lot of people also make the mistake in saying, well, I already put x in right here. I already put x equals -2. What x do I put in there? Well, remember, when you're writing a function or evaluating a function, that's when you plug in x for all the x's in that function. So it doesn't matter if I have 2, 3, 13, 55 x's in my function. I always will evaluate it by plugging in the same number for all the x's. So now we can go over and solve this. So -4 equals a times, those change to pluses, so -2 plus 3 is 1. -2 times -2, -2 minus 2 is -4. -4 equals -4a. And when you divide both sides by -4, a is equal to 1. So we solve for that missing a value. And remember, x and y will remain variables when we rewrite this. So y equals 1. And you don't have to write that invisible 1. You can if you want. X minus -3, so x plus 3. X minus 2. And we're done. And again, like I said before, you could get out your graphing calculator and double check by plugging in -2 for x and see if you get -4 for y in this equation here. So far, it has been using the correct form of the quadratic and plugging in the information that I gave you. So it's very important, if I'm saying we're in intercept form, that we use intercept form here. If I say vertex form, you got to use vertex form from up here. So what I want you guys to do is I want you to pause a video and try these. You have one in intercept form, so it's like the last one we just did, and one in vertex form, like the first one we did. So give this a pause, go back and review something if you need to, but once you're done, unpause it, and we can see if we got the same answers. All right, so here are the answers. So hopefully these are the solutions that you got for the two equations. You can see my work for both of them and how I got the answers. Again, it's very easy to plug in the correct values in the wrong spot. So just make sure you're being careful. I like to use a highlighter for the first few times just so everything gets placed in the correct spot. The last one was with standard form. And remember, standard form is y equals ax squared plus bx plus c. You'll notice that we have a, b, and c to solve for. And there is a way to do this by hand. but it's a long and tedious process, and we now have technology that assists us in this. So we're going to be using that that technology, our graphing calculators. So what we're going to do, and again, the directions are right here. We want to do detached window. So when we turn on the calculator, we want to press the stat button, which is to the right of the variables that we've been pressing. And then we're going to go to edit. And what we're going to do is we're going to put these 3 points into our list. And how you do that is all the x values will go into L1. So negative, whoops, 2, 0, 2. And for the y values, negative 6, positive 6, and 2. The biggest mistake people make when we're doing this is mix matching your x's and y's in your list 1 and list 2. If negative 2 is your first entry in L1, then the corresponding y value, or in this case negative 6, must be the first entry in L2. It doesn't have to be in the same order. I could have put 0, 6 first, and we would still get the same answer. I just like going in the order that I'm given the points, especially since I put in my L1 first and then I go back and do L2. It just makes it easier for me. So now what we're going to do is we're going to press the stat button. So the screen again, go over to calc. And down here you see quad reg. That stands for quadratic regression. I'm going to hit enter. All this should be okay. What I like to do is I like to store the regression. This part is optional. Okay. And I'll show you why I do that in a minute. And then calculate. So you see it says ax squared plus bx plus c, and it gives us our a, b, and c values. So that means my equation is going to be y equals negative 2x squared plus 2x plus 6. And that's our answer. Now, that optional step I did, where I stored that equation, now if I look at y equals, do you see there's an equation in there? What I told the calculator to do was to take that equation and graph it for me. And this allows me to check my answer a lot quicker. So if I press trace, look at 0, 6, that's 1 point. 2, 2 is another point. And negative 2, negative 6 is a point. You don't have to do that part. You could go back here and do negative 2x squared plus 2x plus 6. And the same thing will happen. It's just while I'm in that screen, I might as well just do it. And you don't have to check your work. I just think it's useful. Why not? If you have the option, if you have the tools in front of you, just do it. All right, now this example here, I know it says solo, and I would normally want you to do it on your own, but just in case, I want to go through these steps again. So stat, edit, and then I'm going to put negative 7, negative 3, and positive 5. So all of those x values. Then for the y values, negative 92, negative 12, negative 44. So that's good. Stat, go over, go down to quad regression. And again, I just like to do this extra step. And we'll calculate. And there is our equation. I'm not going to go through and check it like I did on the other one because you guys get the idea. We have y equals, it was negative 2 x squared plus 0x plus 6. Now, we've talked about this before, that 0x, we don't need to write that. 0 times anything is just 0. So this will be our final equation. So we just finished writing equations of quadratics in all three forms, given the points of the quadratic, a vertex, some x-intercepts, and we were only given just enough information to write the equation. Now we're going to write the equations from tables, and you have a couple options when we do this. So quadratics have what's called a constant second difference. Which means if you calculate the difference between y values and then calculate the difference between that difference, it should all be the same, and that is going to help us find our a value. And we're going to look at the table so you can see that. So it says the vertex is a point between matching y values. So when we graph quadratics, remember we started at the vertex and then we went one x value on each side, and those y values were the same. So we're going to kind of go backwards and look and see where the vertex is. The vertex will be h comma k in the equation. So the x-intercepts are found when y equals 0 on the table. That's how you know it's an x-intercept. And then the x-coordinates are going to be p and q in the equation, and that a value is going to be calculated using the second difference, and it's 1/2 of that second difference. Now up here, in the previous page, we calculated a by using a point on the table and then using the vertex or the x-intercepts. Let us solve for a, and then we plugged it back in. That works as well as what we're going to do here. So if we look at this, we have the vertex right here, and you know that because the y values are the same on both sides of that. And we also have our x-intercepts, -3, 0 and 1, 0. So we could actually write this in both forms, vertex form or intercept form. So to calculate that a value, we're going to take the difference between y values. 0 minus 10 is -10. -6 minus 0 is -6. -8 minus -6. Okay, so -8 plus 6 is -2. -6 minus -8 is +2. 0 minus -6 is 6, and 10 minus 0 is 10. So this row is our first difference. Our second difference is when we take these values and subtract them. So -6 minus -10. Okay. So -6 plus 10 is 4. -2 minus -6 is also going to be 4. 2 minus -2 is 4. And then when we don't have negatives, it's a lot easier to see. 6 minus 2 is 4, and 10 minus 6 is 4. So 4 is our second difference. So that means in our equation, a equals half of that, or 2. So over here, the equation in intercept form is going to be y equals 2, then x plus 3 times x minus 1. So we didn't have to use a point to solve for a and then plug it back in. We were able to calculate a using the second difference. Either way is okay. The vertex is -1, 8. No, sorry, -1, -8. Domain, since it's a quadratic, is -infinity, infinity. Axis of symmetry is x equals the x coordinate of the vertex, so -1. Range, so the y values keep going up. We had -8, -6, 0, and 10. So the smallest y value we see in this table is -8, and we go all the way to infinity. Minimum and maximum, because we are going to infinity, we have a minimum value at y equals -8, or the y coordinate of our vertex. End behavior. End behavior, we know, and you could even look at this equation that we wrote. We know that this quadratic opens up because a is positive, so that means as x approaches -infinity, y approaches positive infinity, and as x approaches positive infinity, y also approaches positive infinity. So, and we've talked about it before with quadratics, the end behavior and the range should match with each other. All right, so we have this problem here, and we look at the y values. We see the vertex is right here at 2, 3, because it's in the middle of these two y values. So vertex is 2, 3, which means our axis of symmetry is x equals 2. Now the equation, you say, well, which form do you want the equation in? You could use any form you want, but I don't see any x-intercepts in this table. I don't see y equals 0 anywhere, so our x-intercepts are not found from this table, so we have to use vertex form. So we're going to calculate all of these differences. 7.5 minus 11 is 3.5. 5 minus 7.5 is 2.5. Sorry, these are negative. 3.5 minus 5 is negative 1.5. 3 minus 3.5 is negative 0.5. 3.5 minus 3 is positive 0.5. And 5 minus 3.5 is 1.5. So that's our first difference. And then our second difference, okay, and you can start anywhere you want. Like for some people, they say, okay, 1.5 minus 0.5 is 1. 0.5 minus negative 0.5 is 1, just so that they can see that, all right, our second differences are all 1 if you were to do the subtraction. So the a value is 1 over that, or 1/2. So the vertex form of a quadratic is this: a times x minus h squared plus k. We know our a value is 1/2, and then we're going to have x minus 2 squared plus 3. Our domain, since this is a quadratic, our domain is -infinity, infinity. The range, our a value is positive, so it's going to be the y coordinate of the vertex, infinity. And then end behavior, because a is positive, both ends go up. So as x approaches negative infinity, y approaches positive infinity, and as x approaches positive infinity, y approaches positive infinity as well. And like we said, the end behaviors and the ranges all match. All right, so then this one, we look at our y values and we say, oh, the vertex is right there at -3, +4, so our axis of symmetry is x equals -3. Our equation, Well, we don't have any y-intercepts, so that means we're going to have to use vertex form. So y equals a times x minus h squared plus k. So we need to find that a value. 1 minus negative 8 is positive 9. 4 minus 1 is 3. 1 minus 4 is negative 3. Negative 8 minus 1 is negative 9. Negative 23 minus negative 8. So, okay, we're going to add 8, and we're going to get 15. And then we have negative 44 minus negative 23. Sorry, this is negative 15. That's going to give us negative 21. So then we have to do our second difference. 3 minus 9 is 6. Negative 3 minus 3 is negative 6. Negative 9 minus negative 3 is also negative 6. And then for all of these, our difference is going to be negative 6. So that means our a value, again, is half of that. So negative 6 over 2, which is negative 3. This makes our a value negative 3, so then x minus, so plus 3 plus 4. That is our equation in vertex form. Domain, quadratic, so negative infinity comma infinity. Well, because a is negative, that means our range starts at negative infinity and goes up to the y-coordinate in our vertex. And then our end behavior, because a is negative, both sides are going to go down to negative infinity. And just like the others, our end behaviors and the range, they match. So this was just another way to write equations of quadratics given information. We were given a table, and we used that as instead of a point and the vertex or the intercepts. Either way, like I said, either way is okay. Just whichever is easier for that particular problem. So thanks for watching. Make sure to like this video and subscribe.